Let's talk about subtracting integers. Yesterday we talked about addition. And in our warm-up, I'm having you create some models for this addition. So if we were to look at the first question here, -4 plus 5, and I asked you to create, as the instruction says, model each given expression using the two color counters, what's it going to look like? Well, if I use these color counters down here on the bottom, we can model -4 plus 5. -4 says I need to pull out 4 negatives. So I pull out 4 negatives out of the pile here. And then it says I'm going to add to that, or put in with that, 5 positives. So I bring out 5 positives, put them right here beside the 4 negatives that we have. And if you remember from yesterday, anytime I put a positive and negative together, that makes the value of 0. That is called a 0 pair. So in this particular problem, we have 4 0 pairs that have a value of 0. And all we have left is 1 positive. So -4 plus +5 equals just 1. And what we determined yesterday with our set of rules that we had, that we'll review in just a moment, that if my signs are different, all I really had to do was subtract my numbers. So I would take the 6, because it's the number farthest from 0, and I would subtract 3 from it. So 6 take away 3 is 3, and whichever number had the greatest absolute value, that was the sign that I would use on the answer. So in this case, that would be the negative, -3. Now we also determined that if our signs were alike, that all I really had to do was add them together, because this would mean I would have 2 negatives and 4 more negatives, which actually gives us -6 as an answer. So let's just go over those rules. So what is the procedure for adding integers? Well, the rules that we wrote down yesterday were as follows. If your signs are alike, you add your numbers and keep the sign of the problem. So a +5 and a +3 made a +8. A -4 and a -9 made a -13. And if your signs are different, you would subtract your numbers and take the sign of the number with the greatest absolute value. So here we have a -4 and a +6. Our signs are different, so we subtract. 6 take away 4 is 2. The 6 has the greater absolute value because it's farther away from 0, so my answer is a +2. 5 plus -9, signs are different, so we subtract. 9 take away 5 is 4. The 9 has a greater absolute value, so the answer is a -4. Well, today what I want us to focus on is subtraction. Subtraction is a little bit tougher, okay, when we start talking about integers. So in this particular problem, we have 7 take away 3. Well, if we model exactly like we did yesterday, this says I've got 7 positives, and it says to take away 3 of them. Well, subtraction, that's what that really means, to take away. So if I take these away and get rid of them, I only have 4 left, which is the answer to this problem. Well, that problem really wasn't that tough. It was pretty simple. +7, take away 3 positives, you're left with 4. Same thing goes with this problem. If I've got 6 negatives and I take away 3 of them, I should have 3 left. Well, let's just model it and see. So we've got 6 negatives, and if I take away 3 of them, take them away, and delete them, I'm left with only 3 negatives. So when you have a -6 take away a -3, this -6, I have enough negatives that I can actually take away the 3, and it's no big deal. Works just like regular subtraction, whether it be 2 negatives or 2 positives. But what if I had a +7 take away a -4? Well, if I modeled this one, it says I've got 7 positives, and I want to take away 4 negatives. But in my pile right here in this model that I've got in these integer chips, I don't have any negatives that I can take away. So we have to do something here. Well, for the model, there's one number that I can add to any problem that doesn't change its value, and that is a 0. I can add as many zeros to this as I want, and it never changes its value. But what did 0 look like? If you remember, 0 looked like a positive and a negative. But if you'll notice here, I now have a negative that I can take away, and that's what I'm trying to do. So if I were to add 0 4 times, I now have 4 negatives I could take away. So if I were to take these negatives away and delete them, I now did what the problem told me to do. And if I just add up how many of these I have, it will tell me what my answer is. And if you look at that, you get 7, and you add 4, you end up with 11. Simple as that. But now, we have to ask ourselves, what did I do to this 7 and this 4 in order to get an 11 out of it? Well, really what we did was we had to take the 7 and we had to add 4 in order to get 11. So what we kind of notice is that this minus and this negative, they actually go together to form this plus. And what we find in just a few moments when we go through the rule is that all you have to do to subtract integers is you keep this first number the same, you change your subtraction to addition, and the next number to its opposite, and that allows us to be able to work the problem. Let's see if we can do another one. Here we have a negative 8, take away, positive 6. So if I were to build negative 8, and I need to take away a positive 6, I need to add into this problem 0 pairs that allow me to take away a positive 6, because right now I have no positives to take away. So if I add a 0 there and add another 0, and add another 0, and add another 0, and add another 0, and add one last 0, which actually allows me to have 6 positives that I can take away, because that's what this problem says for me to do. 8 negatives, take away 6 positives. If I take those away, whatever's left is our answer. And you'll notice we have a negative 8 and a negative 6, which really gives us a negative 14. So we had a negative 8 and a negative 6, and I put all that together to make a negative 14. So really what it looks like is happening is this first number, we leave it alone. We change subtraction to addition, next number to its opposite, and that now allows us to do the problem. So our rule for subtraction is very simple. All we have to do is change the subtraction sign to an addition sign, change the next number to its opposite, and then we go back to our add rules, because our problem now becomes an addition problem. So let's see if you can do a couple problems on your own. Take a moment or two to complete these. Okay, let's see how you did. In this first one, we have negative 5 minus 10. So what we need to do to follow this rule is we're going to take the first number, we're going to leave it alone. Leave it a negative 5. We're going to take our subtraction problem, or our subtraction sign, change it to plus, and the next number we're going to turn it to its opposite. Right now it's a positive 10, so we want it to be a negative 10. Now we go back to our add rules. Our signs are alike, so we add them, and we end up with negative 15. Well, what about the 12 minus 6? Well, 12 minus 6, as you know, we could actually do that one. Positive 12, take away positive 6, gives us 6. But does the rule actually work? Well, leave the 12 alone, change subtraction to addition, the next number to its opposite. We go back to our addition rules. Our signs are different, so we subtract our numbers. 12 take away 6 is 6, and you take the sign of the number with the greatest absolute value, which we know is 12. So it does actually work. Well, what if I have more than 2 numbers? Well, then we just do the process a couple times. So the negative 9, we leave alone. We change this subtraction to addition, the next number to its opposite. So the negative 7 turns to a positive 7. And then we just keep the process going. This minus turns to a plus. The 5, because it's positive, turns to a negative 5. Now this will allow me to take my 9 and my 5 and put those together because they are alike. So negative 9 and negative 5 make negative 14. And now I have negative 14 plus 7. My signs are different, so I subtract my numbers and I get negative 7. One last one. We've got a negative 37. We leave it alone. We change subtraction to addition, and the next number to its opposite, which ends up being a positive 42. So negative 37 and positive 42, our signs are different. We subtract, and we end up with a positive 5. So in subtraction, it's really simple. All we do is change the subtraction sign to an addition sign, the next number to its opposite, and then we revert back to our addition rules. Until next time.